Okay, so this one is about how do we write the chemical formula using the periodic table or the ion table when you're given the word. So we're now moving into writing chemical reactions where quite often the product is going to be given to us as a word, and what we need to do is be able to put it into a symbol so we can eventually balance it. So I've got some simple ones to start with. So we've got magnesium chloride. Now the chloride just means that it is chemically bonded. The reason this is an easier one is because it actually just has the two elements in it. So we can just use the periodic table for this one. So we've got sodium and we've got chloride over here. Sodium as an ion, if we wanted to look at it at the table, it's sodium positive 1. Chloride, if we wanted to look at it as a table, is negative 1. So in order to make this ionic compound, sodium chloride, which is just table salt, we only need one of each. So the symbols would just be that. Now it can exist as a solid, as you would have on your table. It can exist as an aqueous solution, which is what you would have in salt water or the ocean. And it can be a liquid as well, and they in fact use it in some renewable resource generation as a way of storing heat energy. So NaCl, remember lowercase, lowercase, the capitals indicate that it's mu element. Again, we can do this magnesium chloride. It's only got the two. It's got magnesium and it has chloride, or chlorine if it's by itself. We know that chlorine has a negative 1. We have a look at what magnesium is. It's in group 2 here, which means, and it's giving up, so it's going to be positive 2. And again, we write our charges as superscript. Now, there's an imbalance here. This has got 2 electrons that it's gotten rid of, and this is only taking 1, so we actually need to have 2 of these to balance it out, which makes it magnesium chloride. Potassium hydroxide. Now we're starting to move into something a little bit trickier. So we've got potassium, that's pretty easy, that's K, and we can look at it and it's got a positive 1 charge. The hydroxide, oxide means oxygen, hydro means hydrogen, so it's actually a polyatomic ion, which we can find on our chart here. And as a polyatomic ion, it's bonded covalently and it has 1 space for an extra electron. So it works out well because potassium is getting rid of 1, hydroxide takes 1, so we don't need to have multiple ones of that. So we just write it as that, and it would be pronounced as potassium hydroxide. The next one is only 2. It's aluminium oxide, so you're going to have aluminium and oxygen, and hopefully at this point in time you've got oxygen down pat. Oxygen, if we look at its charge, it's 2 negative, so it gains 2 electrons. Aluminium loses 3, and this is where we need to be a little bit tricky. So what you can do is a simple way of doing this is you can cross multiply, and you might have heard that term in maths. We're going to put the 2 in here and we're going to put the 3 in here, and the way we would write it over here would be aluminium 2, oxygen 3. So they're accounted for in subscript. When we talk about how many atoms we've got in chemical formulae, the number is written down the bottom. You might have also noticed we get rid of the charges once it's bonded because this compound can't be charged. Alright, let's try for a couple of polyatomic ones. So we've got ammonium, I should say, it's a different compound entirely. Ammonium nitrate. So we have a look. Ammonium is NaH4 positive. Nitrate is here, NO3 negative. The charges are balanced, so this one's got 1, this one's got 1, so we would write it as NH4, NO3. 3. Now, we do not collect the nitrogens together. You would not write N5H4O3 because that is a different compound. All right, so we have got 1 ammonium and 1 nitrate. Now, we'll look at some transition metals because I did say that we needed to look at those. Now, what indicates that it's a transition metal is this one here, and it tells us which one is involved in the reaction. So, iron 3 has a 3 positive charge. Iron 2 has a 2 positive charge. So you can start to work this out. Now, sometimes I think tin and lead can have a 4 positive charge, but that will be indicated with the Roman numeral 4, which is a 1 and a B. We're not dealing with those today. So iron, we write it as Fe. So again, we can find it on our periodic table. Fe, 2 positive. Sulfate is 2 negative, which we can find in our polyatomic ions, which means these charges balance. 2 positive, 2 negative makes it an overall neutral charge. For iron 3, however, we may have to do something else. So if you remember back to our previous one where we did aluminium oxide, we're going to cross multiply. So this 2 is going to go in front of the iron, and this 3 is going to go in front of the sulfate, so that we end up with 2 Fe3 positive, 3 sulfate to make Fe2 brackets sulfate 3. Now, common mistake would be forgetting the brackets, because if you write it just like this, there's some confusion there. You could be saying that there are 43 oxygens. You could be saying that there are 12 oxygens. So that is an incorrect way of writing that formula. Remember the brackets because you are talking about that as a compound together, as a molecule. Okay, so write it with the brackets involved.